we have code bases in Microsoft that are upwards of.
So when you were building C#, you wrote the compiler in C#.
No.
What goes into building a new language? Welcome to a special episode of Dev Questions. I'm here at Build with Anders Hejlsberg. Anders, welcome. Thank you for being here.
Yeah. Mm-hmm.
If you're not familiar, Anders is kind of the founder of C#. We're primarily a C# channel, and so we want to talk to you more about that. But let's get started with what goes into building a new language. I'm sure is not much. It's pretty simple, but
Well, I think first of all, like knowledge of a lot of other contemporary programming languages, because we all sort of stand on the shoulders of giants, right? Every new programming language eventually is 90% not new, right? Because you gotta have expressions, and you gotta have this, and you gotta have a way of just defining types and so forth, right? So I think it's important first of all to have a deep and solid understanding of how languages work and their history and so forth, and the different families of programming languages, functional versus object-oriented versus procedural and so forth, right? And then I think there's both science and art in creating programming languages. I mean, there's an enormously long history, like the compilers go back as long as computers, pretty much. And so there's a lot of established science around how you construct a compiler and a programming language, right? There's a lot of theory around semantics and type systems and Turing completeness and whatever, so you sort of got to master that. But then there's also sort of an art of making it feel right to code in.
Okay.
Do you know what I mean? And that one is like harder to teach, I would say. It's more like you know it when you see it, kind of.
Okay, yep. That definition.
But it probably comes from having written a lot of code and going, this I don't like. This does not feel right to me. If I had my own language, this would not be the way it was done, right?
Which you've done a few times.
Which I have done a few times now, yeah. Although C# was the first language that I actually designed, right?
Okay.
I implemented Turbo Pascal, but Pascal was already a defined language defined by Niklas Wirth. And so I wrote an implementation of Pascal, and then Delphi was sort of a follow-on to that, right? But C# was, ground up.
So what were the initial thoughts around C#? Why build C#? What were the initial goals that you were looking at?
I think, we were building a new runtime platform, a new modern runtime platform called .NET, which it wasn't called .NET at the time, but it was eventually called .NET. And we knew that we were going to have memory safety and garbage collection and exception handling and bytecodes and a whole bunch of concepts that we wanted to capitalize on to make programmers more productive. And then also at that time, and we got to sort of rewind now to the late 90s, we sort of had two contemporary programming stacks at the time. There was Visual Basic with rapid application development, and then there was C++ for, like power and expressiveness and native code and so forth. And the odd reality of the time was that everyone really wanted a little bit of both of those worlds. They wanted the ease of use of Visual Basic, but with the power and expressiveness of C++, right? And they wanted it on a modern platform as opposed to COM and Ole and all of these, like fairly low-level infrastructures we were building stuff on at the time. And so that was sort of the marching orders for C#, create a programming language with the power and expressiveness of Visual Basic, but with the ease of use of Visual Basic and power and expressiveness of C++. And we knew from the get-go that we wanted to appeal to the curly braces crowd, if you will, and that sort of be rooted in C, right? But still we definitely wanted to capture some of that, make it easy to write an app. Don't bother me with a bunch of ceremony all the time and so forth. So, yeah.
Excellent.
Yeah.
Now, I mean, it's been, 20 plus years since that came out?
Well, the first, actually, we're coming up, I think June of 2000 was the PDC, the Professional Developers Conference, where we first released or announced C# and gave out the first preview beta copies.
25 years.
25 years.
Yeah.
Believe it or not. It's amazing.
That's a long time for a language.
Well, is it?
I mean, this is true. It's a long
actually, it's not even that old of a language, right? I mean, my gosh,
true.
You look at that. We were just talking about Visual Basic and C++, right? And
this is
like
true.
Fortran and COBOL and what have you. It's mid-age, I would say.
Gotcha.
Yeah.
So in that, I mean, looking back at what you started with and your original aspirations for C#, do you think that that has evolved over time, or have the core tenets really stayed true to C#?
I think, I mean, from the get-go, we designed C# to be an object-oriented programming language. And those are sort of the core concepts, right? Classes and inheritance and interfaces and what have you. We had some new concepts in there that hadn't really seen first-class treatment in programming languages before, like properties and events and, I think over time, we have adopted a lot of influences from functional programming languages. Like when we got to C# 3.0 with Link, which was really sort of an application of, I'd say, applied functional programming patterns, right?
Sure.
We got lambda expressions and sort of the ability to dot together, sequences of operators, right, in a fluent style, that we didn't have before. So over time, it has incorporated more, and we've learned a lot from functional programming languages, in particular from F#, which is a sister language on the platform, right?
Right. So do you see the next 25 years of C#, big changes, or more a gradual changing of how it works?
It's going to be gradual because, like every language has a lifetime arc, if you will, right? Version 1.0 is a total green field.
Sure.
Lots of things get put down. Then 2.0, 3.0, you're sort of filling in the gaps that you didn't get to in 1.0.
Yeah.
And at that point, you are now sort of on the longer asymptote, I think, of you got to think more carefully about what you adopt, because otherwise it just becomes a kitchen sink language, right? And you don't want that. And you can't fundamentally change the nature of the beast. I mean, like I said, C# is at heart an object-oriented programming language. We can add functional programming constructs, but we can't make it into a first-class functional programming language, because they go a whole different way typically in getting to their solution space, right? So I think it's going to be more gradual, but I think there's still plenty of evolution left that's possible, absolutely. And I still participate in the design of the language, only more we have the language design review board that meets like every month or every 2 months to review proposed new features and give feedback and ideas, and so yeah.
Some more management.
Huh? No. It's purely technical. I don't do. I have never had people report to me, and I never will. So I am not a manager.
Gotcha.
I am purely an engineer.
Excellent.
Yeah.
Excellent. So yeah, looking at C# and the breadth of the language, there's a lot that has grown and matured over time. And one of the things looking at from a more kind of brownfield type experience is the fact that you can't just take things out.
Correct.
So
yes.
There's things in there that maybe you did things differently in the future, but you have to leave in for the past.
Yep.
How does that affect that decision-making process going forward, looking at things saying, we don't love this.
Right.
But we can't just rip it out because of existing customers, existing applications.
Exactly. Yeah. No, and I'm glad you bring that up, because a lot of languages try. to rip stuff out.
Sure.
And it never ends well. I mean, at least not if you have a user base, right?
Right.
I often joke, show me the perfect programming language and I'll show you a programming language with no users, because that's the only language that can constantly change and be perfect, Once you commit to something, it both becomes a feature and it becomes baggage at the same time, right? Because if you then discover, there's actually a better way and whatever, well, now what? And I think we try to evaluate new ideas on sort of, I have this, it's not at all a scientific method, but I often say, every new feature you propose in the programming language starts out with minus 500 points. And now it has to just win 500 points just to get to a point where we would even consider putting it in. Because adding anything new adds aggregate noise and more learning curve and whatever, right? And I think the world is guilty of shipping lots of minus 200 pointers. Do you know what I mean? That it made it better, but it also it ends up this cacophony, right? So often our job is to just go, we'd love to do something in that space, but it's not ready yet. It's not in positive point territory yet.
Right. So actually, speed is a negative in a lot of ways. Going too fast means you cause too much chaos.
Oh, exactly. Yeah, and then you're going to ruin it for yourself because, like you said, you can never take it out. The minute you put it in, someone will use it. And now if you try to take it out, you break their app, right?
Yep, exactly.
And if you try to, come up with compiler switches to enable and disable, then you make the learning curve even bigger, right? I mean, and so you just got to be real careful.
Gotcha. Yeah. Well, and that's the thing that, we look at, the change come in C# 14 or, on down the road, and it seems like they're tweaks and they're changes rather than this massive new feature, this massive new area.
It's all you can do when you're as established as C# is, right? I mean, if you're in the what are we in the top 5 programming languages in the world or thereabouts, right? I mean, it's you don't get to.
It's the responsible way of doing things, right?
Parts of the foundation out at that point, or build new things on top of it. It's just steady as she goes. Yeah.
Sure.
Yeah.
So when you were building C#, you wrote the compiler in C#.
No.
Okay.
Not the first one.
Okay.
The first one was it was written in C++.
Okay.
Or, as I sometimes say, in C++, because we we didn't use all of the features of C++. But we didn't have a compiler.
Right.
And so we didn't. So there was no bootstrapping that we did at that point. We did later.
Okay.
But the first one was actually written in C++.
So tell me about the transition between the C++ compiler then the C# compiler and how that went.
Well, oddly, we actually had the command line compiler, and then we also had a separate lighter weight compiler for IntelliSense in the IDE. We're talking back in the early days. And that was horrendously hard to deal with because we would go, first we had to go implement the feature, and then we had to go implement the feature over and over, and they were always out of sync, and the compiler we had in the IDE, for IntelliSense and whatever, took some shortcuts which at the time it was designed seemed to make sense because, hey, in an IDE you got to be fast and therefore you can't do everything, and therefore, well, it turns out you actually can do everything. You just got to be smarter about how you do it. But we didn't have the smarts at the time, and so we didn't do it that way. But that sort of went on for years, and then eventually was the genesis for what became the Roslyn project, the rewriting of the compiler in itself. So writing the C# compiler in itself and writing a single compiler that could be both the command line compiler and the compiler that the language service uses. And there's a whole art to how to do that.
I'm sure.
Because, when you think command line compiler, fine. It's like you feed it a bunch of text and magic happens in a box, and then out comes assemblies or whatever, bytecode or object code or whatever, right? But you think about the compiler in the IDE, well, first of all, it's never going from never fully compiling the program. I mean, that's part of it if you ask for all the error messages. But when you're just typing in the editor and you press dot and you want statement completion, how do you do that fast enough? If your program is huge and it takes, like, say, 15 seconds to compile the whole thing, you can't wait 15 seconds every time you press dot. So now you got to do something incrementally in order to get to the answer fast. And trying to architect a compiler to both be something that can be a command line compiler that can check everything, but also something that can do just the minimal amount of work when you're typing, because we know from user studies that if it takes more than 250 milliseconds to deliver that dropdown, then people think the IDE is slow, right? And not responsive enough.
Yep.
And that's tricky.
Sure.
And so you gotta really come up with some interesting data structures to make this possible. You got to think deeply about how do we defer work and make the compiler completely lazy. How do we give the compiler the sort of ability to helicopter into the middle of a program and start asking questions right here without first having to establish the deeper context that this piece of code sits in. Let's say it's nested in a function, in a class, in a module, in a whatever, How do you not, like, first have to build all of that up in order to answer the question in there? And so that was a big learning curve. I think we came up with some really interesting solutions there that we've then subsequently applied in how we built the TypeScript compiler. And it's paid off in spades. I mean, we can, in both of these language services, they're excellent. You can load gigantic projects and then just type away, and it's just super snappy and responsive.
So you started in C++, but you switched over to C#. What was the thought process behind why use C# and not continue with C++?
Well, self-hosting is huge, right? And also productivity. I mean, honestly, writing in C++ is not a particularly productive experience, right? C#, it just, things are way easier, right? And you can be way more productive. And you can also, I mean, and I've always been a big believer in self-hosting, and so we wanted to write in our own language so we could feel for ourselves what needed fixing and what wasn't performant enough, and, so, yeah.
So you find the primary pain points yourself before you ship to the customer.
Oh, there's nothing better than that. Yes, yeah. Because if it sucks, it before it even gets to customers, right? It's really only the situations where the customer code exhibits something out of the ordinary that you wouldn't know about, right? So
because you've experienced it first. Excellent.
Yes, yeah.
So, I mean, you mentioned TypeScript, and TypeScript did the same thing. TypeScript has a compiler that was built in TypeScript.
Yes, well, it has been so far.
Correct. And I want to talk about that.
Yes.
But let's start with the first. I mean, it's the same thought process behind it was we want to build in TypeScript in order to experience those pain points first.
It was.
And eliminate.
Yes. I think, well, TypeScript is pretty unique because, again, we're not talking about a new language now. We're talking about retrofitting a type system on top of an existing language, which is yet again a new sort of. That was what made the project interesting to me, right? Because that's like, oh, okay, I don't think who's done that before. That I want in on that and try some of that. And we knew that in order to appeal to the ECMAScript community, or the JavaScript community, you had to be of the JavaScript community. And we also had to really get to learn deep down what is the nature, the gestalt of this JavaScript programming language and the Node platform and so forth. And the best way to do that is to use the platform to write the compiler. We also knew that we wanted to. TypeScript is very much affinitized with front end and browsers and whatever, and we wanted an artifact that we could run in the browser. And because TypeScript is written in TypeScript, i.e., therefore runs as JavaScript, the TypeScript compiler is perfectly happy to run in a browser. I mean, our playground, it's the full compiler. It's like it's right there. It doesn't need a server to talk to. No. It does it all right there. That's how. And like the early Monaco, the beginnings of Visual Studio Code with TypeScript integrated into it, that was all like running in JavaScript in the browser. But I will also say that if someone had told me now it's been 15 years with TypeScript, but if someone had told me 15 plus years ago that, Anders, you're going to spend over a decade writing compilers in JavaScript, I would have gone, hell, that's never going to happen. Yeah. And yet it did. Right?
Yeah, sure.
And it served us well. It really has. But there are limits to what you can wring out of the JavaScript execution environment.
And you hit those.
And you hit them. And we have hit them pretty hard. I will say I think the TypeScript compiler it's an excellent compiler. It is very well written. Given the millstones that it's forced to carry around, it runs incredibly fast. But it is locked in an execution environment that has a very expensive execution model. It's JIT-based, JIT compiled. You got to start from scratch, and like all you get is source text, and now you got to run it, right? I mean, so you got to turn it into code first. That takes time. It has a very expensive object model. Objects in JavaScript are really more like dictionaries or maps. Like you can just dot into anything. Or you can even add a new property like midstream, and now it has this property that it didn't have before. I mean, how do you make that be performant, right? And then JavaScript comes with, because of its browser origins, it is effectively forced to be single-threaded. It runs on a single thread, the UI thread, in the browser, and it can never block because that locks up the browser.
Yep.
Hence all of these callbacks that you have to do in JavaScript, that run asynchronously and so forth. And now, of course, over time, we've patched it a bit by supporting web workers, which is effectively the ability to spawn a new execution environment and give it some code and have it run. But the execution environments can't share any structured data. They can pass messages to each other as JSON or they can pass byte arrays, but you can't have one web worker make a graph of objects and then give it to some other web worker to operate on. Nope, it can't be done. So we've the TypeScript has sort of been locked in an execution environment that's very expensive and been forced to run single-threaded. And those are two big millstones to carry around, right?
They are.
Yes, and we know now that each of them comes with a 3 to 4x penalty. And they are multiplicative, right? Meaning that you're talking 10x if you could be not forced to
be in those boxes.
Well, not forced to be JIT compiled and have an expensive object model, and not forced to run single-threaded. And that's effectively how our port to native code gains its 10x. It's half from being in native code and half from having the ability to take care of concurrency. And I mean, if you look at a colleague of mine, Herb Sutter, who used to run who was on our C++ team as our representative in the standardization committee, whatever, he wrote a paper about 20 years ago called "The Free Lunch is Over." And what he talked about in that paper is how Moore's law keeps going, but at that point it stopped giving us faster CPUs, and it instead started giving us more CPUs.
Okay. Yep.
The clock rate sort of went up, and then it plateaued around 4 gigahertz or wherever it is we are, and now we just get more cores.
Right.
And if you have compute-intensive workloads, which a compiler is, the only way you can make it faster is to use those cores.
Right.
It's never going to get faster on a single thread, So
you're leaving a lot on the table by not.
So you're leaving money on the table. You're leaving more money on the table every year because we get more and more cores every year. So that's all we're going to get from here on out.
So you're looking at that massive compiler, and there's a lot of work that went into building the TypeScript compiler.
Yeah.
And you've got what essentially is a massive brownfield application.
Yep.
And you're almost starting over from scratch? I mean, you're not, because you're trying to port.
Oh, yeah. No, we knew from day one that this was going to be a port. If we started from first principles, oh my Lord, we would. I mean, it is just way too big. I mean, TypeScript is now. Well, I mean, certainly, if you look on GitHub, it's the number 3 programming language after JavaScript, after Python. But if you put together JavaScript and TypeScript, then they're number 1. So I mean, and today the two have become so commingled, right? And it's like our compiler. Whenever you're doing anything with JavaScript in Visual Studio Code, you're using our compiler. That's the one that delivers the language service for JavaScript and TypeScript. Okay. And it just, if there's no types in your code, fine. Well, it'll have to infer as best it can, but it's the same compiler. It's the same infrastructure, right? So we have an enormous amount of dependencies out there. And we can't just start over from scratch and expect to ever finish. You know, but we can port, and that's basically what this effort has been about. It's literally we want to port so that we get precisely the same semantics, so that we get precisely the same types computed or inferred for the same piece of code. We literally want to be able to open a drawer, take out the old compiler, put in the new compiler, close the drawer again, and you never know the difference. That's the plan.
That's
and it's working out. It's
good.
It's working out really well. Yeah.
Well, that's my next question is how's that going? And
it's going great.
Excellent.
Yeah. I mean, we started out thinking that we could get to 10x because that's what our prototypes seem to indicate. Now we know that we can get to 10x because we're getting 10x consistently on large code bases like Visual Studio Code that today with the old compiler takes about 60, 70 seconds to compile, takes 6 seconds to compile with the new compiler. And if you go in anywhere and introduce an error, it produces precisely the same error message. You can't tell the difference between these two. It just goes 10 times faster.
Excellent.
And this bears itself out with other large code bases that we've tried. We have code bases in Microsoft that are upwards of 15 million lines of code. Like, I'm not going to name names, but
massive, yeah.
Code bases that we could never even load in Visual Studio that now load in 15 seconds. You know, I mean, this is like. I mean, like Node would just choke, you know, and now it's possible for us to, so the scaling has just gone through the roof here, our ability to scale, which is really wonderful. And we can see that we've also managed to successfully parallelize all the phases of compilation, which in turn means we can harvest concurrency wildly, not just, you know, in the... Well, if you think about how a compiler works, you know, it has certain phases of compilation, like parsing, binding, checking, and emit are sort of the phases that we have in our compiler. And some of them are what I would say are embarrassingly parallel problems, where, you know, for example, parsing a source file. Well, it consists of load the file and then build a data structure that allows you to quickly navigate the file and find stuff in it and have objects that describe the different pieces of the source code, right? But it's completely independent for each file. So you can start a task, run that on one CPU, and if you have 32 CPUs, you can start 32 files at the same time. And that scales linearly, right? And parsing, which is the construction of simple tables, the first pass locally over each of the trees, also scales linearly. Emit scales linearly, but checking doesn't. But we've come up with some really clever solutions to how we manage to scale almost linearly for checking. And we're seeing it play out now. I mean, you get some of these like crazy in the cloud dev boxes with 32 cores and 128 gigs of memory, and you allow it to just use all the cores. And you literally see the CPU monitor, all of them just going full throttle. Like to compile these 15 million lines of code I talked about, compiling all of it in 45 seconds. It used to not even be possible to do it, but if you chunked it up, you could get it, but it would take like I mean, half an hour or something. I mean, it's just nuts how it scales. So
you're improving developer productivity by
yes. Oh,
improving
absolutely.
the compiler productivity.
We're making the world greener. We're consuming less energy. We don't need a data center to run our compiler anymore.
The green new effort, right? Yep, excellent. So, I mean, you've kind of scratched some itches, I'm sure, for yourself, writing Turbo Pascal and then Delphi and then getting this into C# and TypeScript. Mm-hmm. I'm just curious. Is there another itch at some point you want to scratch, build a new language, or are you thinking like, I kind of want to time out here and stay where I'm at?
Well, I'm not as young as I used to be, and I will eventually retire. I mean, I'm in my mid-60s now, close to. But I enjoy what I do. I still get up every morning, make coffee, and write some code. And it's what keeps me happy. I've tried being a manager. I've tried being a product manager or whatever. I don't like. I want to write code.
Excellent.
And I'm still pretty good at it. So and then it's fun. So I'm going to keep writing code. I don't know what that code's going to do. Right now, I know I'm committed for the next year to finish and get to TypeScript 7, which will be the release vehicle for the new native code base. And then we'll see.
Excellent.
Yeah.
So, I mean, you kind of touched on something there that a lot of developers miss, or you're looking at your career trajectory. It feels like it's, junior dev, mid-level developer, senior developer, manager.
Yeah.
And you're saying, I don't want to do that.
Well, I think, some people discover at that point that they really have a passion for management and they enjoy doing that. For me, that's not my passion. My passion truly is writing code and solving complicated technical or algorithmic problems. That's what keeps me happy. And I think you're never going to do your best work if you're not passionate about it. You may do good work, but if you want to do truly great work, there's got to be a fire burning or some passion there behind it. Do you know what I mean? And
I do. Yes.
Yeah.
Excellent. Yeah.
So for me, that's the right thing to do for me. But I mean, it's not for everybody.
but I think that's the example that people miss is often they see that in order to progress, I have to do this management step, and you can. Well,
and I think you have to be honest with yourself at that point, and you have to look at it. You go, but can it fulfill me? And I learned that it couldn't fulfill me. I got involved in more and more task forces and slideware and presentations and specs and whatever, and I was just like burning out. Like in my middle years at Microsoft at one point, and I sort of had to I was either going to leave or I was going to reset, and chose to take time off and reset and get involved in say no more. Do you know what I mean?
I do.
And,
yes.
and it's hard because you have ambition and you don't want to, but at the end of the day, you got to be true to yourself too.
Find that right outlet for your skills and abilities.
Yeah.
Excellent.
Yeah.
Turning back to C#, this is a primarily C# channel, primarily C# audience. Mm-hmm. You've seen how C# is used over the years. Is there areas of C# or C# adjacent you feel like people are missing, or that they don't utilize as often, or things you're like, that's an awesome feature and I think you're missing it? Is there one of those? I mean, I'm kind of putting you on a spot here, but
no, I mean I am hoping that the world will really open its eyes to how serious the C# team and .NET are about open source and being on all platforms. And I know that has been sort of a change from where it started originally, but it's interesting. It was always built to be a general purpose runtime that could go anywhere, but for other reasons it was not. It was just not sold that way in the beginning. But now that we're open source and that we're on Linux and Mac, and have .NET Core and have extracted out all of the core pieces of the runtime, and we're starting to have a better ahead of time compilation story and whatever. It really is in many ways a different product than, but you know, again, it's like it's hard to change people's perceptions, right?
Sure.
But I do think C# has a lot more legs than it's sometimes, you know, perceived to have. Yeah.
I agree.
Yeah.
All right. Well, I appreciate you being here.
Oh, my pleasure.
Thanks so much.
A fun conversation. Yeah.
And that's it for this episode of Dev Questions. And as always, I am Tim Corey.